So today we're going to be talking about the galvanic cell, specifically the type of redox reaction that occurs in order to generate energy or electricity. A galvanic cell, also known as a voltaic cell, is one of the first early, most primitive batteries. In this case, ours is set up with a copper metal bar right here, a zinc bar over here, and in the middle a salt bridge. And the salt can be multiple different things, but in this case we're using NaSO4. The liquids in either of them can be something like water, just a solution that will help the copper and the zinc lose electrons. And the top up here, you can see this wire. This is what connects them and completes the circuit. So when copper and zinc are submerged into their respective containers, what happens is they start to lose electrons. And when they do that, they break off into little particles that are now in solution. In zinc's case, zinc 2 plus and copper 2 plus. And when it does this, actually zinc will lose its electrons slightly faster than copper. So when it does this, this electron right here will start moving around and rushing up and meeting back up to where this copper is. Now, most of the copper is going to be broken apart. When it does this, it'll slowly move its way down until it reaches where all of these copper 2 pluses are floating around in solution. What will happen is they'll join back together, remaking neutral copper, which will then form back into the bar, or onto the bar. Now, the reason we have this salt bridge is because over time, this side of the solution, with the zinc, is becoming incredibly positive. The zinc over time, as you can see, it's already +2, it'll make a very, very positive solution. Meanwhile, over here, we have plenty of spare electrons running around over on this side. So all these electrons are going to make the copper side very negative. So in order to counteract this, we use a salt bridge. Now what happens is that this NaSO4 is going to break apart into Na plus and SO4 minus. The Na plus will move its way down into the negative side of the solution as it's attracted to that, and it will help start neutralizing this, keeping it as a more neutral state. Meanwhile, the SO4 2 minus will make its way into the positive side and begin neutralizing that. All of this is in an attempt to keep the charge very neutral of these two solutions, because if the charge becomes too negative or too positive, it can disrupt the flow of electrons and stop the flow of electricity around the circuit. So here we can see the actual reaction that's taking place. Zinc plus copper 2 plus becomes copper plus zinc 2 plus. Now if we break that down into its sub-reactions, what we're going to have is zinc becomes zinc 2 plus 2 electrons. Now the oxidation number of zinc starts at 0 and increases to 2. And since it's losing electrons, we know that zinc is oxidizing, making it the reducing agent. On the other side of this reaction, we have copper 2 plus 2 electrons becomes neutral copper. Now, copper's oxidation number reduces. It goes from 2 plus to 0. And since it's gaining electrons, it's the oxidizing agent.